So guys, in this video, we're going to talk about volume, and specifically volume of prisms and cylinders. So remember that volume is just how much space something occupies. So let's take a deck of cards. Okay, notice that the deck of cards almost looks like a prism, looks like a rectangular prism. But if I think about how much space does that occupy, let's go back down to just a single card. A single card set has about 63 millimeters across and 89 millimeters tall. Okay, so if I wanted to find just the area of one deck of card, remember that's just base times height. So we could do 63 millimeters times 89 millimeters, and that gives us 5,607 millimeters squared. All right, so that's just one deck of card. But if I go ahead and stack all of these cards on one another, so if I do this card on top of that card, and then if you think about how many cards are in a deck of cards, anyone know? Well, that's 52 cards are in a deck of cards. So if I have 52 cards and they're each 5,607 millimeters squared, then can't I just say that I'm going to multiply that 5607 by 52? That's how much space they take up, because that's what they are stacked up together. So if I wanted to find the volume of this, it would just be 5607. That's the area of each card, and I would multiply by how many there are. And that's a really big number. It's 291,564, 291,564 millimeters cubed. Okay, take another example. Let's say we have some coins. Oh, I went backwards. So if I have some coins, let's say I have a penny, and a penny is 9 millimeters across. Well, if I just want to know how much area is one single penny, all right, so that's just pi times radius squared. So I could do pi times 9 squared, which is 81 pi. So if I then take those pennies and stack them on each other, then they take up space. Right? They take up more space than just one single penny laid flat. So this amount of space that they take up depends on how many I put in that stack. So I just put 4 in the stack, 4 pennies. So in this stack is going to take up 4 pennies, and each penny is 81 pi. So the amount of space all of those take up is going to be 4 times 81, which is 324 pi. Or if we wanted to get a decimal, that would be 1,117.9 millimeters cubed. So if you think about it, we're basically just taking the shape of that base and we're stacking them up and counting how many we're stacking up. So let's go to our guided notes, and we're looking at volume of cylinders, and here's our formula. So the volume formula, we're just going to be doing area of the base. So remember, this is like either your card, the area of a card, or an area of a penny. And then the height of the figure, that's like how many of them we had. Okay, so let's go to our first example. In this one, we have a rectangular prism. I'm going to call this 3x5 rectangle my base. So the area of the base is going to be base times height, and that's just going to be 3 times 5, which is 15. And then my height is going to be 8. So for the volume, all I'm doing is doing 15 times 8. And when I do that, it gives me 120. And my units on this one is going to be inches cubed. Remember, volume is in 3 dimensions, so we have inches cubed, not inches squared or just plain old inches. All right, let's go over to the triangular prism. Here, the base is a triangle. Remember, it's not what it's sitting on necessarily. It's the shape that's different than the rectangle. So the area of the base of a triangle is 1/2 base times height. So I have 1/2. The base of this triangle is 4, and then the height of the triangle is 3. So if I do 1/2 base times height, that gives me 6. And then the height, remember, is not necessarily vertical height. It's the distance between those two triangles. So that's 2. So for my volume, all I'm doing is doing 6 times 2, and that gives me 12 meters cubed. All right, and down here, I have a hexagonal prism. So remember that on this one, we have to find the area of the hexagon. So let's do that second. I'm going to make sure we know the height first. Remember, the height goes from hexagon to hexagon, from front to back. So that's 8. And the formula for area of a hexagon is 1/2 apothem times perimeter. So let's see if we can find the perimeter. Perimeter is going to be all the sides added up. And remember, this is a regular hexagon, so all of those sides are 6. And I have 6 sides, so I'm going to do 6 times 6. So my perimeter is 36. Now remember, when we don't know the apothem, they didn't give that to us, we have to do those 3 steps that we talked about. So we're going to start by finding our central angle, and that's doing 360 divided by 6. That gives me 60. Then we're going to half that, cut that in half, make that half triangle that we've been doing. So half of this, if I divide that by 2, that gives me 30 degrees. So 30 degrees goes in here. And if I do half of the base, that's going to be 3, because I did half of 6, and that gives me 3. And the apothem is this side. So we're going to do our SOHCAHTOA, that's tangent of 30 equals 3 divided by A. Cross multiply. Remember, that's like over 1. So if we cross multiply, I'm going to get A tangent of 30 equals 3. And I'm dividing both sides by tangent of 30. So if I do that, 3 divided by tangent of 30, it's going to give me 3 root 3. Okay, so we have our apothem and we have our perimeter, so we're ready to do the area of the base. So I'm going to do 1/2 times 3 root 3 times 36. And then that gives me 93.53, and I've rounded. So I should do approximately that. So my base is 93.53, and I have my pieces for my volume. So to do volume, all I'm doing is area of the base, that's 93.53 times 8. And that gives me about 748.24 meters cubed. So that's my volume. Now, if we think about cylinders, cylinders have a special kind of base that's a circle. So specifically, you might want to write down your volume of a cylinder is pi r squared times height. All right, so when I'm doing B on a cylinder, it's always pi r squared. Now in this diagram in number 3, the radius they tell us is 3. So the B part is 9 pi. And then they tell me that the height of the cylinder is 4. So when I do volume, I'm just doing 9 pi times 4, which is 36 pi. And that would be feet cubed. Now in the book, they might do that as a decimal. So if you type that in, you should get about 113.1. Now going over here, remember this in our diagram, this 12 is referring to the diameter. So the radius is not 12, the radius always is half of that. It's half of 12. So our radius here is 6. So when we do our base, make sure you're doing pi times 6 squared, which is 36 pi. And then my height of my cylinder, remember that goes from circle to circle, so that goes this way. That's 10. So my volume is going to be base, which is 36 pi, times my height, which is 10. So that'll be 360 times pi. So it's really just 10 times more than our last answer. And that's in feet still. And if I wanted to round that, that should be about 1,131. So we'll do more practice with volume in class.